Hello, my name is Suchitra Das. Today I am going to explain my internship project which I did during my internship at EMERTXE Institute for Embedded System. The internship project is basically focused on implementation of microwave oven simulation and microcontroller development board. Further details will be discussed in the presentation. Now let us discuss about the learning outcomes of the internships are fundamentals of C. In the fundamental of C language, we learned about basics of loops such as for loop, while loop and do while loop and the difference between all the three loops. We actually learned about the use of C for embedded programming which include the use of function, how to define a function, bitwise operator, how to create a mask, and bitwise manipulation using the mask. We are introduced to the embedded system, different types of embedded system, and the use of Big Genius development board through the project microcontroller, which is a 8-bit architecture microcontroller. We learned about microcontroller architecture and applied it during our application project. Next, I will discuss the application project itself. First, going through the PicGenius development board, it includes the PIC16F877A microcontroller, which is a 8-bit microcontroller. It have 33 input-output pins and 5 I/O ports also. The development board has various I/O devices attached to it, which are shown on the figure on the right side. We mainly used port B and port D, which has the LED and LCD display. We also use the buzzer and timer for our application. Further, we discussed the important concept used in the project. Here we use a 8-bit timer, which is a timer that counts from 0 to 255. For every 255, it takes the timer to clock and that generates an interrupt which can be pulled. We also learned about the timer pre-scaling and post-scaling. The pre-scaling is nothing but dividing the input frequency of the timer by a certain number. The post-scaling is just opposite of it. It divided the output of the timer. These are used to have more control and configure the time of the applications. Timer initialize is done by setting various configuration options. Using the specified bits of timer we are used in our code. Next, the microwave control flow of the system. We have some functions which are used to initialize, which includes like the CLCD, the keypad initialization, timer configurations. We have some functions which are used to operate the operation modes, which mainly include the cooking mode, display, time display, and the pause and stop capability. Now we have also the user interaction, which include the key press handling in display, update functions used to interact with the user, and some functions which are used to interact with the system such as buzzer, fan control, power management, etc. Next, the microwave operation cycle, which is shown in the figure. First is the initialization of the system, which occurs at the start of the system. Then we read keypad input from the user and we change the operation mode according to the user input. The display displays the mode of information which show the current mode and the settings. Also, we manage the cooking timer, and we take input from the user related to the cooking time, and we have capability to pause and stop the operation also. So it's a continuous cycle flow which occurs in a while loop, while the initialization of the systems only once at the start of the program. This will be the basic architecture of PIXIM lab, and it will be the pin diagram of PIC16F877A. In PIXIM lab, the PIC16 will be connected through the 7 different IO ports, whereas in pin diagram it will show clearly the pins will be 1 to 40. From 1 it will be VPP and 2 ANO, whereas from 11 pin give VDD. So this is the basic pin diagram of PIC16F877A. So now coming to the interrupt. All that interrupt are specially signals that temporarily halt the normal execution of a program to handle the urgent task. It can do the work, then handle the program, and that will very crucial and very important. It is the signal to the processor and interface by hardware and software, indicating and that needed immediate attention. Whenever interrupt occurs, the microcontroller complete the execution of the current instruction. There are mainly two types of interrupt, such as hardware interrupt and software interrupt. Interrupt can also be used for interrupt handling process, such as interrupt occurs the current execution stops, ISR execution, ISR completion, program execution. So coming to the ISR, ISR means inter-service rating. It's a function that executes and inters occurs when the interrupt perform the task. ISR will do the work of. It must be short and fast. Next, I will be discuss on the timers. It is used in everywhere. In embedded system, we also use timers. It used to generate accurate time delay. So it's a simple binary counter that used to count the call. It will roll back to 0 and setting open the overflag and generates the interrupt enable. Now I will discuss about the CLCD. The CLCD stands for Character Liquid Crystal Display, which is used for displaying ASCII character and some special characters. It is the most commonly used display in the embedded system. It has two communication methods, 4-bit mode and 8-bit mode. In our PIXIM lab, the two major types of display are 16 cross 2 display and 16 cross 4 display. Start the tactile switches. These are the electromechanical devices used to start or stop the flow of current through the circuit. They provide simple and cheap interfacing and are preferable if the number of user inputs are very less. Tactile switches are momentary switches that turn on. They are pushed. They are used to control small currents and signal input for various electronic devices. They also provide feedback of the push operation through tactile sensation such as a click feel. Let's discuss about the matrix keypad. And this is the keypad in which the number of tactile switches are connected in a rows and column format. This is used when more number of user inputs are required and still want to save some controller I/O lines. These keypads are most commonly used in telephone, calculators, digital lockers, etc. The matrix keypad is the most commonly used input devices in many of the applications areas like digital circuit, telephone, communication, calculator, etc. A matrix keypad consists of a set of push buttons or switches which are arranging in a matrix format of rows and columns. These keypads format at rows and column, and these keypads are available in configuration like 3x4 and 4x4 based on the application its implementations. Now let's look at the project demo and the presentations. So this is the code that we have written in the MP lab. There is a CLCD code. In CLCD we have source file and header file. In the source file that will paste to the display on the screen, whereas the header file can be recalled from function header to the source. These are the program that we used on the project. So coming to the output of the program, it will be here. So here this is the basic PixSimLab design. This is the 16x4 CLCD display, and this is the cooler and heater, and this is the buzzer, and these are the pins, and this is the PIC16F877A microcontroller, and these are the LEDs, and this is the reset button, and this is a matrix keypad, etc. So this is the output shown in the CLCD screen. When we press button 1, it will be micro mode. That's shown power equal to 900 watt. Then we given this timer, and this is the here the hash means we enter the program, and star means clear the program. So when we enter program, the cooler will be running. When it runs, we can say that the micro oven is working. And when we want to stop, we press 6. That show enjoy your meal. Reel mode we do the same. We can give the timer, then enter, and it will run. And coming to the main menu, when we press 3, convection mode is active. We have to set the temperature and enter. It will preheating this cooler fan will running until the time will be 0. If you want to stop this, just press 6. If you want to starting from beginning, then you press the reset button. So this is the overview of the project that I made in this internship given by the EMERTXE Information Technology for Embedded System. So thank you my all the teachers and mentors, my guiders and all my friends.